Good morning, ladies. So, at this stage, you should be able to tell me that an electric field surrounds a charged object, and we can represent that electric field with electric field lines. Today, we are going to look at electric field calculations. So now we want to be able to calculate the strength of the electric field. Now, if you take a look over here, according to our guidelines, the electric field strength at a point is the electrostatic force experienced per unit positive charge placed at that point. So that gives us our first formula that we can use to calculate the strength of the electric field. So you can see over here, as per our definition, electric field strength is force per charge. Now, force, we know, is measured in Newton, and charge is measured in Coulomb, and that is where our unit comes from. For electric field strength, it is newtons per Coulomb. Now, let's take a look at a simple example of what this calculation would look like. A charge of positive 5 nanocoulomb, so there's our charge, experiences a force of 4 times 10 to the power of negative 6 newtons, so there's our force, at a point in an electric field. Calculate the strength of the electric field. So I've got Q, I know that it must be in Coulomb, so I've converted nanocoulombs to coulombs. I've got the force, and I want to work out the strength of the field. So we've seen that electric field strength is equal to force divided by charge. The force was given as 4 times 10 to the power of negative 6. The charge we've converted to coulombs, so 5 times 10 to the power of negative 9, which gives us an answer of 800 newtons per coulomb. So very important to understand, when I use this formula, I'm calculating the strength of the electric field at a point where a charge is placed. So I'm calculating the electric field strength at a point where I know what the charge is and I know what the force is that the charge experiences. And this force is my electrostatic force, so I can calculate that force using Coulomb's law. Right, then there is a second formula that we can use to calculate the strength of the electric field, and this one looks like this. Electric field strength, the unit is still newtons per coulomb, is equal to K, and it's still Coulomb's constant, so 9 times 10 to the power of 9. Q is charge, and R squared is distance from the charge, and distance must be in meters. Now this formula shows us that the strength of the electric field is directly proportional to the charge. So as we said, when we looked at electric field patterns, if I've got a charge with a greater magnitude, there will be a stronger field surrounding it. And then the other thing is, electric field strength is inversely proportional to distance squared. So that just means the greater the distance from the charge, the smaller the electric field strength is going to be. Now let's take a look also at a simple example of where I will use that formula. What is the magnitude and direction of the electric field 1,5 meters away from a positive charge of 2,1 nanocoulomb? So I want to work out E. I've got R, it is in meters, I don't have to convert. The charge is given as 2,1 nanocoulombs, and I've converted that to coulombs. And that means I now need to use this formula. So if you just take a look at this illustration here, now I want to find the strength of the field a certain distance away from a charge. So K is Coulomb's constant, 9 times 10 to the power of 9. Q is that charge over there. And R is the distance away from the charge where I want to find the strength of the field, which is 1,5 for this question, and it's r squared. So the answer that I got is 8,40 newtons per coulomb. They also ask for direction, and because this is a positive charge, I know that this is what the field is going to look like, because I always use a positive test charge to find the direction of the field. So I know the field will be away from the charge, and that is why over here I said away from the charge, or some people prefer to describe it as outwards. Okay, over here I've got some simple examples of questions that you can go through and you can practice using those two formulas. And what we'll then do next is look at some more advanced examples of questions on electric field strength calculations. Thank you, ladies.